Okay, well, I guess welcome everybody to the second installment of Gold Nuggets, which is the HE interview series that we're doing. Who haven't heard about it that much, what we're doing is we're interviewing people from all the different disciplines across the campus to kind of get what their take is on humanitarian engineering. Last week or last month, or about a month and a half ago, they interviewed Marty Gutierrez, I think from geology. This week we have Kevin Moore from electrical engineering, and then I think next month we're going to be doing somebody from the geophysics department. So that's kind of the overall gist of it. And this week we'd like to, I guess, say thanks and welcome Kevin Moore, or Dr. Kevin Moore. He's the executive director of the Humanitarian Engineering Program and the director of the Mines Robotics. He's held many other leadership positions in the past at Colorado School of Mines and other research institutions. And a lot of his research focuses on control systems and robotics. I'm sure there's many other things that he could tell you about what he's done, and I'll let him do that. But yeah, thanks for being here, Kevin.
Thank you. Thanks, Kevin, for inviting me. I had a chance to review some of the first interviews, and I really like the series and the idea of trying to connect humanitarian engineering to the disciplines. So I look forward to talking with you tonight. Thanks for the invitation.
Cool. Well, the first question that we have is kind of an introductory question. Basically, can you just tell me a little bit more about yourself and how you got where you are today, and kind of at the end being involved within humanitarian engineering, just again, so everybody on the call can know a little bit more about you.
Yeah, sure. In the introductions, you described me as being the executive director of humanitarian engineering, and I could imagine a number of people on the call saying, "What?" Juan and Jessica are the directors, and that's true. We have a plethora of directors, but let me explain that a little. I've been at Mines for 15 years, and for the last 9 years, I was in leadership as an academic dean. So you can think of that as your faculty member's boss's boss. And in that capacity, when I took on that role as dean in around 2012, I took it on myself in a way to kind of revive the humanitarian engineering program. And so I think it's helpful to talk about the humanitarian engineering program briefly. That program started at Mines as a minor in 2003 with a grant from the Hewlett Foundation. And about 450 students did projects, about 50 projects in multiple countries all over the world. And about 50 students got a minor in humanitarian engineering over a 6-year period. And then the money ran out and the program kind of went into kind of a hibernation of sorts. There was even a white paper at the university commissioned by a provost to figure out what to do with it, because it started to develop a name recognition. So when I became a dean, I was interested in the program. I knew about it when I came here and I wanted to see it survive. And I convinced the acting provost to bring Juan Lucina on as the director of the program. He was not the director prior to that. And we did a big curricular revamp, and we developed a relationship with Chuck and Luann Schultz and obtained a gift and got the program going. And so I kind of have always had a connection to and an interest in the program and where it went. And when I stepped down from being dean, there was a desire expressed by Chuck and Luann to have somebody working in the program to start to fundraise to make it more sustainable so it doesn't run out of money again. And that's where that executive director title comes. But I'll just kind of reassure the group that Juan Lucina remains the director of the undergraduate program Jessica Smith, the director of the graduate program, and Julia is the person that makes everything happen. And so that's a little bit about my time at Mines. I showed up here in 2005 as an electrical engineering professor, and it's sitting in an endowed chair doing research in control systems and robotics. I paid a little too much attention, as I like to say, and I ended up in leadership. If you talk in meetings and volunteer for things, pretty soon you find that they're asking you to take them over. So that's a word of warning to the students that are listening as you head out into your career, or a word of advice, depending on where you want to go. I'll just say prior to that, I think I came out of South Louisiana. I was kind of a medium-sized fish in a very little pond. Grew up out in the boonies, went to LSU, moved to the big city of LA and got a master's degree and worked at Hughes Aircraft. And relative to humanitarian engineering, I actually can dig up my college essays when I was looking for grad schools. And what I said was I wanted to study materials to develop new photovoltaic devices that would save the world from their energy crisis. So I was writing that in 1982. But an interesting thing happened on the way to grad school and the professorship. I started studying materials and I hated it. Frankly, I just couldn't hack the chemistry. I didn't like it and I didn't do well. I got C's. So I took a controls course as an elective in my master's program and I loved it and I got A's. And I spent a whole summer soul searching in the library and switched to the controls area. And, you know, I think it's another bit of advice or warning, but you'll do better work if you really like what you're doing. And so it is important to find that. And I think you can find ways to merge a passion for making a difference with your passions for the material you're studying. It's always possible. So so then I moved on and got a PhD and moved on to a professorship and started doing what professors do, research teaching. Yeah, I actually ended up doing a lot of control theory applied to materials, interestingly. So material processing. So a lot of things come back around. And yeah, eventually I found my way to mines. There's another part to that story because I kind of moved from materials to robotics. And then September 11th, 2001 happened. And I was doing military-based robotics, security robots, and I wanted to do that in a bigger way. So I actually quit my professorship, flat out quit, gave away my tenured position and moved to a defense lab. And again, after about a year, I hated it. I thought I was gonna like save the world with security robots, and I found out that in a defense lab, you spend a lot of time writing proposals and writing more proposals and writing more proposals. And I didn't get to do as much work. And that's what led me to mines. There was an opening. I knew about humanitarian engineering. Actually, that's another side story. I knew about humanitarian engineering because when I was at USAT State as a professor, I applied for that $1 million from the Hewlett Foundation to develop a different type of senior design. And they turned me down and they gave the money to mines. I still remember seeing Colorado School of Mines, where is that? How did they get this grant? And we had a good proposal. But so I knew about HE, and when there was an opening here, that was in the back of my mind, and I decided to apply, and I ended up here. So that's a little about me and where I came from.
So one question that I would have about that, and you touched on this a little bit, is like, what advice would you have for people? You kind of said like, you know, follow your passion because that's probably going to be like what you'll be most successful in and it will make you happy. I know sometimes, especially with HE, like I think other people struggle. Like it seems like you kind of have to be an environmental engineer because everything's environmental engineering, or you have to choose this path. So what advice would you give to especially to undergrads or postgrads, about, being able to still follow your passion of, I really like controls or whatever it is, but also kind of, especially within the engineering profession, being able to apply that to something like HE.
Yeah. Well, you know, um, I'm not going to say it's easy. Like, if what you really like is designing semiconductor chips, that's a highly technical, specialized thing that takes place in a computer and sitting in a cubicle a lot of times when it comes down to actually trying to put the chip together and maybe do the VHDL design and get all the layers laid out and so you can eventually send it off to a fab. And this may not be immediately obvious how that's going to connect, but I think for a lot of fields, it depends on how close to the ground you want to be and how 30,000 foot you're looking at where your impact's going to be made. You could be part of a team writing the Android software, or you could be part of a team, developing cell phones, and that's just like a consumer product. But on the long view, the cell phones have some good and bad components, and some of those good components are they've enabled millions and millions of perhaps we would say underserved populations in Africa to take part in modern banking because of the cell phone technologies that have enabled them to get access to banking when they couldn't actually do it through the traditional banks. So there's always these derivative effects that you could look at. At the same time, if you want to start looking at whatever your engineering discipline is and where it can come to apply in a humanitarian engineering aspect, I like to think of Maslow's hierarchy of needs. So at that bottom layer are the physiological needs, and then there are safety needs and love and belonging needs and esteem needs. So you can start asking yourself actively, where are these technical things that I love going to be applied to meeting these needs and at what level? So I think, Kevin, you and I were chatting recently, and we talked about the IEEE has been running, I think they're in their 12th year, it's called the Global Humanitarian Technology Conference. And a lot of what's happened there is very much focused at technology that people can use on a daily basis, whether it's LED lighting in a village that doesn't have grid power, whether it's the ability of putting in small microgrids to provide power. But when you mention like environmental engineers or civil engineers are the ones who are maybe able to really go out and apply the HE, it's because they're addressing these fundamental infrastructure things that people need. I'll tell you a story about that, and not to take too much long, and I'll date myself, but you can stream all this on Netflix. There was a show that well, I'd probably say liberal Democrat types like. It was called The West Wing, and it ran for a number of years, and it was kind of supposing an altruistic president was in the White House and the struggles they had trying to do good. Well, the show eventually ended, and the outgoing press secretary was approached in like the last episode by a philanthropist, and the philanthropist said, "I'm going to give you $1 billion foundation to run. Well, what are you going to do with it?" And she said, "Oh, I would build roads in Africa." And he's like, "What? No. Don't we want to end AIDS and get rid of HIV or something?" He said, "Oh yeah, no, that'll come. But first you need to build roads Then you need to give people toilets and clean water. And then you need to give them a sustainable source of food and a stable economy. And those things will lead to peace. And when you have a strong system, peaceful setting, that'll lead to education, which will then create a positive feedback loop to help amplify these effects. And that'll end AIDS eventually. So I think that's another way of looking at that Maslow hierarchy of needs. So for a double E, you have technical things you like. Look and see where those things meet people's needs at the most basic levels. And then at the next levels, and again, I hold up the cell phone, a little scary. On this hierarchy of needs, you've got safety, love and belonging, esteem. Well, the cell phone and the connectivity it can provide can give you love and belonging and connectivity. It could also give you self-esteem problems, depending on if it's in the wrong hands, right? And you're logging onto the wrong site. So it starts to get complicated, but you can insert yourself into that pyramid through all manner of disciplines, in my opinion.
Mm-hmm. So I guess, and that makes a ton of sense. And that's kind of looking at it from the lens of you and I, and I'm sure a lot of people here, in that, we think we're kind of already of the mindset, like wherever I want to be, I want to be making the most positive impact. And like, kind of like you said early on, when you, I think, applied to grad school, that you wanted to save the world with photovoltaics. Yeah, and I feel like that's like a lot of our mindsets here. But what do you think about, like, or I guess, what would you say, like, what responsibilities do you think engineers just have in general, to make sure that their tools are being developed in socially just ways? So, one thing that comes to my mind is, like, I think Elon Musk is, trying to make his Starlink so all of Africa can have internet. And I don't know the engineering behind it or anything, but like, I guess kind of like, what responsibilities do you think the engineers who are working on that, like, it is just a good product, right? Hopefully there's more internet and people can be more connected, but there's a lot of other, like, socially just implications that might be there beyond just, okay, everybody has internet. And so I guess what responsibilities do you think that we have as engineers?
Well, responsibilities that we have to make sure the tools we're developing are used sustainably and ethically. I think we have to approach that kind of in a categorical type of way. I like to think about intention. And I mean, is your intention good or is your intention bad? I also like to think about the effect. Is it having an expected or intended effect in the technology you're developing, or are there unintended consequences? And so there are kind of four possibilities there. And I think, if your intention is good and your intended effect is good, maybe the people developing drones did it because it was cool, but the drone technology now enables people to find lost hikers and to count animals in a game reserve and to keep track of where the forest fire hotspots are at, and to deliver COVID tests. That was just in a news thing I got today. So those are all great things, but then an actor with bad will takes the drone and uses it to deliver a bomb. Is the person, and I can tell you, when I started this business 20 years ago, or a little before with the robotics, you didn't have octo and quad rotor drones because the autopilots had not been developed. They were not commercially viable to be cheap and usable in every little hobby shop DIJ drone that you can buy anywhere. So, and I have friends, and I actually did some work, but none of mine was commercialized. But I have friends that commercialized some of the early autopilots that actually make these drones work. So I don't think that friend would take personal responsibility because someone bought a drone that had his autopilot control software in it and they used it to deliver a bomb. That's not something he can control. So I think, I mean, I would like to say the engineering profession writ large, it's a fundamental concept that it's built into our code of ethics, our codes of professional codes of ethics that we should be holding the public welfare to our utmost concern. But you can only take that as far as to what you can control. And if my friend said, well, I'm not going to design that autopilot because I know eventually someone is going to use it for bad. Someone else will design the autopilot. Bad people know how to design things too. And but I think you should take responsibility for that you can control. And you may find you can control more than you think. You can control where you work and what the values of that workplace are. Once you're in that workplace, you can control how you relate to your colleagues and what values you put forward. You may not be allowed to practice those values fully, at which time you could leave that workplace. I think you could control things like the sourcing of materials in your products that you design. But I think these answers are also variable. If you're working for a construction company that's building a major hydro dam, you know, you could choose to do that because you believe that hydro dam was good in generating renewable energy that is going to help the climate change. And that's a large scale, lower on the hierarchy thing. It's easier to understand. But when you pick up something like the cell phone I keep holding up, it's a consumer product. And I think what people do as consumer products are different than how infrastructure is used in the public interest. So all engineers have some responsibility for the impact of their actions, and they need to understand how it affects stakeholders and community. But I don't think you can not design item X because of the possible unintended consequence by someone with bad intention. Those are some thoughts I have about it. I haven't actually ever taken an ethics class or talked about these things in a social sciences type setting. So so there may be better answers than mine.
I think that's a very good answer. I think especially just realizing that like you can't control everything, but you know, control what you can and then just make sure that your intent is good. I think sometimes is kind of, I guess, maybe the best that you can do. And it kind of leads into one of my next questions. And you answered this again with the intent, but like, how do you think us as engineers can, because obviously the world is complex, all systems are complex. With every, you know, thing that you do, there's, you know, a million different like ripple effects that you have no clue or no control over. How do you think you can balance, you know, the whatever you do, create, make, design, engineer, like how do you think you balance trying to make sure that you're doing it in the most socially just way, you know, trying to make sure that the materials are sustainably sourced, trying to make sure that it will be used for good reasons and not bad reasons. You know, you could you could spend, you know, almost your entire life, and I mean that's what I think a lot of the people almost at HE do, is make sure that engineers use their designs in good ways. But how do you think you, as an engineer who's just saying, maybe they tell you, oh, design this robot, or you're a chemical engineer, design, this piece, this type of food, or whatever it is. How do you think you can, try and be socially just about it, but still be able to design it? And I know it'll be an ongoing process for sure, but I guess, how do you think you can kind of hit that middle ground of, yes, I've tried to make sure it's sustainably sourced. I've tried to make sure, it's a good product, I guess, while still being able to develop it. And especially if you're in a corporate situation where people might tell you, okay, you have 10 weeks or a year to design this robot, go, and you might not have, you can't spend an entire month like researching where all your sources are coming from.
Right. Um, you know, a lot of this discussion I have with Juan Lucena and Jessica Smith and others in the faculty, Dean Nuzma and from Civil Environmental, Jim Komar, and Nicole Smith in mining, Julia, our associate director, lots of other faculty that have been involved. We do discuss to a large degree what is humanitarian engineering, and how is it maybe different than other engineerings, but at the end of the day, the word engineering is there, and engineering is something that probably everyone on the phone understands. If you're far enough along, it's never about the right answer. Engineering is about finding a solution that meets the needs and provides, kind of the best optimization towards meeting those needs against all the constraints. There are always multiple answers that can solve your problem, but one will be better according to some criteria than others' criteria. So this might come back to things you can control at some level. If you're in a company and you can work your way up and become respected for your decisions, you can begin to influence those criteria in the direction of corporate social responsibility. If you're still entry level, you're still designing and sourcing those products, and you find that your company is not paying attention to things like just product sourcing, it may be you have to leave that company. But because there's never a right answer, there are always feasible answers from which you try to pick the one that will work best. You have the opportunity then, especially having had training in humanitarian engineering precepts, the general notion of social responsibility and socially responsible engineering, you have the choice to try to begin to influence how you define best in that setting you're in. And I think we know more and more the larger corporate world understands this. Professor Smith can talk more about that, but mining was kind of first, and then oil and gas kind of started coming along. Interestingly, as an example, we have an alum from mines who came out of applied math and statistics, who's currently at Facebook, but she spent, I think, like 12 years at Hewlett Packard Enterprises running a group that was responsible to ensure that there were no, I don't know the right word, no metals entering into Hewlett Packard Enterprise products that were obtained unjustly, specifically out of Africa, with some of the minerals in their components. So they actually tracked something like 1,200 suppliers, and they tracked the sources of the metals that they're using, and tried to ensure they're only buying from those that were obtained justly. So lots of companies are moving that direction, even in aerospace defense. So I think what graduates of the School of Mines who go into those corporate settings can do is first of all, look and only go into those settings where they determined ahead of time that these companies are caring or starting to show they care. But the other is to begin influencing what best means in the designs they do. And yeah, if you're asked to bias a transistor by picking a couple of resistors and making a feedback loop around it, I mean, in that design, that may not have a lot of leeway to work with, right? But as you move through your career, you're going to find yourself in more and more of a position to make those influences.
You do you have any suggestions for people who are just starting off their careers? And I know a lot of this is you're kind of limited by the, you know, just by the fact that if you choose to go into a more corporate role, that you're kind of like lower on the totem pole. But do you have suggestions to people who are just starting off their careers who might feel like, okay, I want to maybe work for a corporation, or they feel like that's kind of their only choice? And obviously, once you get higher up, you can make more decisions. But do you have suggestions for people who are potentially lower down or just starting?
Well, I think that if your goal is from the beginning to be influencing things in the direction of humanitarian engineering, really making solid differences in the world quickly, you actually just need to move more to types of companies that are working at the infrastructure level. That's electric power, and even like, I mean, we're talking kind of yourself and myself from an electrical engineering point of view, which was where I came out of. But if you look at water, I mean, electrical engineering is essential to providing clean water. You've got to have pumps and motors, and and today you've got to have communication. If you're looking at the need for lighting, that's not kerosene lamps or wood burning, that's electrical engineering that's going to help. So infrastructure, aiming towards infrastructure companies is going to be a starting place. There are also a lot of things around communications that it's also very infrastructure related. And in fact, IEEE and the Association for Computing Machinery, ACM, which is the computer science professional organization, they have been the leaders in the world in trying to provide access to connectivity in rural settings. And especially in this pandemic, this is a huge social justice issue. We are seeing lots of reports about how far behind underserved populations are getting in school, with school kids not being able to have the connectivity. And in fact, interesting in that regard, this is electro and mechanical, but we're talking with some folks at Red Rocks trying to maybe go after some money, working with some schools in Edgewater. You got all these school buses sitting out there not doing much. They've got a lot of homeless kids that go to the public schools that don't have access to Wi-Fi and don't have a lot of food. So there's a project in the works to try to take these school buses and turn them into mobile high Wi-Fi hotspots and act as a mobile food bank at the same time, and go and park them out in the neighborhoods where their kids are coming from. Actually, a lot of the kids have been given laptops as loaners and stuff, but they don't have connectivity. Well, that's a huge double E type of thing. And you could find companies working on those problems. Now, if you go to work at Lockheed, I mean, I don't want to say that you're not able to do things that are socially responsible at Lockheed. I think actually aerospace defense. So here's a conundrum for you. In aerospace defense, there's something called offsets. And if we, if one of our companies sells a bunch of missiles to another company, to another country, they're going to pay us to get our missiles. Well, then we have to pay them some money, and they use that to set up some small industries and companies in their country to help the people in the country. That's called an offset. And that's something about, that's part of how international arms activity works. So you might give them money to start a company to build holders for the missiles that we sell them. But so even that has some humanitarian aspects, although the conundrum is that really a humanitarian if you're doing that with missiles? But that kind of thing happens with lots of international trade, not just defense. So there's a lot of back and forth and tit for tat. So, but I'll throw another one out there, and unfortunately, my social worker wife is not listening because she gets angry when I talk about things like sending people to Mars, because her sense of social justice is, that's stupid. Why would you send someone to Mars when there are people starving in inner cities in the United States? Well, I get that. If you take a longer view, we are going to run out of minerals. There's this huge problem right now. We want to solve climate change. I mean, that's a social justice issue. Well, we need to quit burning so much. We need to quit burning so much coal and oil and gas, and we need more electric cars on the road. We don't need all these little inefficient combustion engines. So let's replace them with electric. Oh, but we need lithium ion batteries. Oh, we need lithium. Oh, the Chinese own it all, and they even own the mines in Chile where there's some more. So we've got a problem. We've got a supply chain problem on our minerals. Oh, maybe we can get them from the asteroids. Or, well, it looks like actually we might be able to. So from the long view, if the planet population doesn't stabilize, we need Lockheed helping us get to outer space eventually. But that's not tangible, perhaps. And maybe it's even rationalizing working for Lockheed instead of working for an NGO putting up LED lighting. I can't answer that for an individual. I worked at Hughes Aircraft for 3 years. I actually designed control systems for radars on fighter jets. I felt okay about that work. Okay, would I do that work today? I don't know. I was young, but people down the hall from me designed autopilots for cruise missiles. I think even at that time, I wouldn't have felt okay about that work. If they used the same theory that I knew, I could have done that work too, although I wasn't asked, but I was capable. So sometimes when you're working in that big corporate setting, you might just have to say, I'm not going to do that work. Switch departments or something. Yeah, but I don't think that's very concise advice. There's not going to be a good one answer fits every person starting their career.
I guess kind of on that note, and going back to you, what would you say is some of the most interesting or impactful work that you've done as an engineer, especially like within relationship to serving people who are traditionally not served by engineering?
Well, the first thing you said was interesting. So actually, I love the smell of burning metal. The most interesting work that I've done was that I worked on control systems for iron melting furnaces. 70% of the iron in the US is melted in big, tall furnaces called cupolas. And that's like a very ancient type of thing. And I also worked in alumina reduction, where they take alumina ore and melt it and in big pots in what's called a pot cell. And the molten alumina comes to the top. And I worked in welding. So like those didn't affect necessarily underserved people. You're part of the supply chain, whether it's iron or aluminum or welding for that matter. Um, in terms of impactful, the other word you said, uh, in my own career, we commercialized a robot that was used in Iraq and Afghanistan for security. And that was a very intense 6 years of development. We made like 8 different robot designs and 32 total copies, and we commercialized and sent 40 copies into a theater. And anecdotally, one blew up. Anecdotally, cars got out of the inspection line when they saw they were going to be inspected by the robot, and the soldiers were standing behind behind concrete barriers and driving the robots remotely. So that was keeping people out of harm's way. And I can count 10, 15 students, master students and bachelor students who came through my lab that are working in car companies on autonomous vehicles. So I'm a little skeptical on the autonomous vehicles, but I've recently had the chance to have one that has bells and whistles and does I don't even know the correct words, but where it won't let you move over to the side, like if it feels you drifting, or if there's someone in your way and you want to put your blinker on or move over, it'll beep at you. So I see derivative effects for me. I'm educating these students in how to do this autonomous technology. They're going out, they're implementing it. If I had any regrets about that, is that I wasn't quite attuned to humanitarian engineering type ideas, and I didn't necessarily teach those students to question if and when they should be doing that type of work. Because you do have the issues that autonomous cars may kill people unintended. And maybe there's some point where we don't need all those bells and whistles. So in my own case, I think in terms of working with underserved populations, I've sponsored a variety of senior design projects. At times we did work with aquaponics systems, working with Red Rocks again, and the Colorado Grow House, which is not anything to do with marijuana. It's actually about growing fish in community aquaponics systems. But I've also worked a lot in the diversity, inclusion, and access realm at mines. And I think so that's only indirectly been related to my engineering expertise, but bringing more diverse engineers into our pipeline is good for social justice and humanitarian engineering, I would say.
Another question that I would have is, us as engineers, like we're really taught how to kind of like systemize things and put things into blocks and figure out how those things interact. And I think that's it's really important. It kind of is what engineering is, and it's allowed us to create, I think, some of the biggest engineering marvels that we have today. And it can also be used to solve really complex problems. If you're looking at the world in a very socio-technical way, like at a very wide level, like you kind of need to do that. But how would you say you can best avoid kind of engineering out the human aspect? I think kind of an example that pops into my mind is I helped work on the Pyre project this past summer, and even with something like that, with the artisanal small scale gold mining, you're trying to like map out all the systems, but even if you're close to really close to the problem, you still, if you just make a generalization, you're still kind of like at some point engineering out some person. So how do you think you best not engineer out people?
Well, there are people whose face are looking at me on the Zoom. who would be better at answering this question in terms of where I'm going to go with it. One of the things we have to do in engineering education, and I think this is multiple courses, so it's not going to be a 5-minute response in an interview like this to give the answer, but we have to have a truly integrative approach to understanding not just the context in which engineering takes place, which is actually a way I like to describe it a lot of times. But I know in our humanitarian engineering program, there's a lot of discussion about the fact that science and technology to a large degree has been very reductionist. We break things into these parts and these categories like you're talking about, and oh, a human is just one other category. It doesn't actually try to synthesize and construct in an integrative way all of the constraints and considerations. And I am not well enough educated to talk about how that integrative education really needs to happen, and how we teach engineers to keep those people completely tied in as part of the loop, as it were. But I do think some of the ways you do that is especially in the places where it really matters, is that there's never just an engineer designing a solution. It's always a team, and it's not just a team of engineers. It's a team of stakeholders. And I actually think that the bigger world is starting to understand this. The engineering world will come along. Some of the people listening to this interview may be aware there's something called the Business Roundtable. These are mostly, it's a club. It's a pretty fancy club. It's the kind of people that go to Davos and the World Economic Forums, and it's usually CEOs of Fortune 100, Fortune 500 companies. They came out last August, a little over a year ago in 2019, with a statement that said the purpose of corporations is not to meet the needs of the shareholders, but it's to meet the needs of the stakeholders. So shareholders make money when they sell product, when companies sell product to consumers. But consumers are stakeholders in that. They have a stake in what that corporation is doing. These big top chiefs of industry said the stakeholders matter. So I think engineers have to move to the point where they believe the customer truly matters. And that's why we started teaching the human-centered design philosophy in the Cornerstone class, and to begin to build thinking about customer empathy. And it's not just another constraint like cost or weight or size, or, usability. It's not just that. It's the reason we design. And I think if we can ingrain that in the ideas of our engineering students, it only takes 4 to 6 years. I mean, you just got to get like one generation going through it and then keep it rolling. And people will pick up on it. And I do think the bigger world, now the Economist would, maybe that's not something we all read regularly, but I mean, they lambasted the Business Roundtable up and down. They said that's the goofiest thing they ever heard. The point of a corporation is to make money for their shareholders. But the fact that these chiefs of industry said otherwise, I think it gives hope. And engineers will get there too.
What I completely agree with that, and I think that makes me really excited to see that people at the top are starting to change. And I think overall it does seem like as society we're slowly changing. You brought up earlier with like the corporate social responsibility and stuff. One question that I would have, and it's kind of like the last question, and then if we have time we can open it up and see if anybody else has other questions. But what would you say to sometimes, and sometimes I feel like this, or to the engineers, sometimes I feel like a lot of my, not, well, some of my friends are like this, where sometimes it's easier to just see the world in just the numbers and in just the engineering sense. You know, sometimes I really like all my HE classes, they're really interesting, but sometimes I'm tired. And for me personally, it's almost easier to just, you know, go into, you know, I took like with you like feedback controls last semester, and sometimes it's just easier to be like, well, these numbers are just, it's just going to work out. Like I don't have to balance all of these complex, you know, relationships. So what would you say to the student who sometimes feels like that, or maybe always feels like that?
Well, I would say get a job, because when you get a job, the numbers don't ever work out. And really the reality of design in the real world is that it doesn't work out like the textbook examples. And layering on the human element, or rather blending the human element in, it it's not going to make it any harder than the real world design you encounter is going to be, because the human element's already there. Now, that said, there's a saying I like, and I sometimes have this conversation with Juan Lucina. I'm fond of saying somebody, you know, bridges to prosperity can go and interact with a community and do the hard community engagement, social science, and decide that a bridge would be effective and it could go at this location and it could have these constraints to meet the local customs. But eventually, at the end of the day or the middle of the day, perhaps, if somebody hadn't studied indeterminate analysis, that bridge might fall down. And then all of that hard community engagement has gone by the wayside because you've lost the faith and trust. So it's there is a place for these components, and just because at some point in that Bridges to Prosperity project, somebody is sitting in front of a computer running the numbers. And that's what they're doing. And you know, they're part of a team, but it doesn't mean that every team member is going to help run those numbers. The numbers are the numbers. I have too many stories, and sometimes maybe they aren't relevant. But you know, I mean, really, to your point, the numbers. There's a favorite sci-fi short story of mine called "The Cold Equations," and I can't tell you the author. I'd have to look it up. But there's this freighter that goes between planets delivering supplies, and if it can't deliver the supplies, the people on the planet die. Well, this little girl on one of the planets, her brother was on the other planet, and she snuck onto the freighter. Well, that meant that the freighter couldn't get to the planet. It wouldn't have enough fuel. So the cold equations were the little girl had to die or the planet had to die. And for some reason, they couldn't jettison the cargo. So there's some stuff I don't remember about the story, but it was called the cold equations, right? Well, there are always equations that have to be there and have to be worked on. And sometimes they may be cold, but what we want to do with humanitarian engineering is to try to be solving problems and engaging all the stakeholders so that the equations are never actually cold, but they're simply a tool for making the life better. So yeah, I don't know, my cold equations analogy, the story maybe didn't quite fit the answer, but I do think for those that love the numbers, you can still be doing numbers and also be part of and having a mindset of the impact on people.
Cool. I again completely agree. I've really enjoyed this conversation. I'm sure we could talk for hours, but in the interest of time, I think we can begin to wrap it up. If does anybody else have any other questions that kind of popped in their heads during this conversation? If not, thank you again, Dr. Kevin Moore, for being here. I think we can end it. I don't know, Julia, you or Nina wants to shout out the next one, the next interview that's happening, or?
Sure. So I am just checking on my calendar to make sure I have the right date and time. So our next Gold Nuggets interview will be December 2nd at 4:30 p.m. With Dr. Alexis Navari-Stichler. So we hope that y'all can join us for that. I know it's coming quicker, but the end of the semester is coming as quickly. So we wanted to get one more in this semester while we could. To our student and faculty participants, if you have any ideas of someone you'd like to see interviewed as part of this interview series, please feel free to share them with us. We would love to bring in people and invite students in particular to help us conduct those interviews if you're interested. So please don't hesitate to reach out to us if you want to get involved. And thank you, Kevin, Dr. Moore, for an amazing conversation. And as Kevin Green mentioned, we will post this on our website. So if you want to watch it again or share it with friends, please do so. And thanks everyone for joining us.
All right. Thank you very much for having me.
Thanks.